Hello, welcome. Let's try to solve another Leetcode problem. 2291 maximum profit from trading stocks. So for this problem, we are having the present array and the future array. So this means for example, at this place the present stock is 5, and in future it's going to be 8. So this means if we were to buy it, we're gonna spend a budget of $5, and we're gonna make a money of 3 because it's gonna be 8. Yeah. So we want to return the maximum amount of profit you can make. Yeah. So this is gonna be let me just make a drawing about it. So this is going to be a typical 0-1 knapsack problem, because for each of the index we can only take once, and after that definitely we cannot go back and take it again. And we just want to return the maximum amount of profit we can make. And this budget is for 0-1 knapsack, it's like a capacity. We have a capacity of 10, and we want to choose as many stocks as we can, and we want to make as much money as we can. So we're going to have a decision. So for example, we're going to choose like the zeros, third, and the fourth. So for example, this one, the third and the fourth, and we can make a money of like so this is our budget. So we're gonna spend $10, and we're gonna make the money. It's gonna be 8 plus 3 and plus 5. So this is gonna be 8 plus this is 3 and this 5. It's gonna be 16. So 16 minus 10 is gonna be 6, and this is gonna be our profit. And according to all the different cases, 6 is the maximum amount of profit we can make. So we're gonna return 6. Maybe let's just continue to check the second example. For the second example, we have a budget of 6, and we can choose the first and the second stock, and we can make a money of 3 and 4. So it's going to be, we can make money like 7 minus 4, it's going to be 3. But we can also choose the third stock. We're going to buy it with $5, and we're going to sell it with $10. So we can make a profit of $5. So this is going to be the maximum profit we can make, so it's going to be 5. And for the third example, because our budget is 10, so this means we can buy the first and the second stock. But if we buy the first, we cannot make money. Actually, we're going to reduce our budget. It's going to become 0. And if we buy the second stock, it is still the same. So there's no meaning to buy it because it's the same. If we want to buy the third stock, it can make a money of 3. But we don't have such kind of a budget because currently we need to use $12, but our budget is only 10, so this means we cannot make it, we cannot buy it. So we're going to have our final return, it's going to be 0. Yeah. I think the easiest way for solving such kind of problem is going to be the 0-1 knapsack problem. Normally we're going to use a case with DFS. So I'm going to design this DFS. So I'm going to design I and B. So this I means the index of each stock, and this B is going to be the budget. Yeah. So if the budget, it means how much money we spend. If the budget is definitely more than the budget, so I'm going to return a negative infinity. Yeah, so this means for my final result, I'm going to call the DFS from 0 and 0. From the beginning, my budget is 0. So this means my budget can never exceed this budget 10. So finally, I'm going to return the result if the result is not equal to negative infinity. If it is equal to negative infinity, it means I cannot buy anything. I'm going to return a 0. Now let's just start coding. So the next condition for 0-1 knapsack is that I'm going to check this I if it is equal to n. So this means I need to design this n. It's going to be the length of the array. So I'm going to prepare this present. Or you can also prepare the future because they are equal in terms of length. Yeah. Now we're going to continue to check. So if I equals to n, it means it goes out of the boundary. So basically we're going to have a return. So we're going to return 0 if the budget is less than or equal to the budget. If B is less than or equal to the budget, it means we are safe. Yeah. Else if it is more than the budget, definitely it means it's not possible. So we're going to return a negative infinity. And finally, we're going to prepare a result from here. Result is going to be equal to I plus 1 with B. So this means for 0-1 knapsack, for the current index, this means, yeah. So we're going to prepare it as a result. And now we are going to select it. If we want to select it, so in which case we want to select? We have to compare the future and the present. If the present I, this means for this index I, because we can make money. If it is a negative value, definitely there's no meaning to buy it. Yeah. So this means we need to update the result. It's going to be the result with DFS I plus 1 and with this B, and how much money we need to spend, because this B is the budget. So B gonna plus the present I. This means how much money we spend. And we need to plus another value. So this value is gonna be the actual final return for the result. It's gonna be the maximum money we can make. So what's gonna be the maximum money we can make? It's gonna be the future I minus the present I. Yeah. So finally we're gonna return the result. Yeah, I think that's all about it. So the condition is that for this budget, it's going to be bigger and bigger until it is more than the budget. So we're going to have a return of negative infinity. Otherwise, we're going to choose all the values of the maximum. Definitely, we're going to find the maximum profit we can make. If we cannot find it, we're going to return a 0. Let me just run it to have a check. As you can see, it seems it works. Yeah, but we need to be careful about the DFS with memorization, and we need to check this I and B. So for this I, it's going to be 1000 because it is going to be the length of the array, and for this B, it is the budget, so it is 1000. It seems 1000 times 1000 it is okay, but we cannot pass in this example. We have to clear the cache. Let's just submit it to have a check. Yeah, now as you can see, we cannot pass. We only passed 81 testing cases, but we cannot pass all of them. Normally for such cases, we're gonna do a trick, at least in Python. I'm not sure if other language can pass. Maybe other language can pass for such kind of a DFS plus memorization. But for Python, if we have the memory exceeded issues, we're gonna clear the cache, because for each of the DFS, we're gonna record the result. And now we clear the cache. Otherwise, the cache gonna become bigger and bigger. Definitely, it will not work. So we're gonna clear the cache for such cases. So after clear the cache, it's gonna be okay. Let me just run it and submit it to have a check if we can pass after clearing the cache. Yeah, so the cache is for the DFS. Yeah, as you can see, now it works, and the time complexity is O(n) squared. N gonna be the length of the array and the target, because they are equal, so it's going to be O(n) squared. Yeah. I think that's all about it. Basically, it's a very basic 0-1 knapsack problem, and definitely it's going to be a good problem, because this way it is just simulated the 0-1 knapsack. And thank you for watching. See you next time.